All right, today we're looking at the Pythagorean theorem. That's great. Theorem versus the distance formula. So here, find the distance of our line segment using both Pythagorean theorem and the distance formula. Remember, we always got to do our answers in simplest radical form. So let's go do the Pythagorean theorem first. That means I'm going to turn this thing into a right triangle here. Okay. So this is going to be my A, which is going to be 2. This is my B, which is going to be 2. I am looking for the C. Remember, the Pythagorean theorem is A squared plus B squared, which is equal to C squared then. A is going to be 2, so I have 2 to the second power, plus 2 to the second power, and that's equal to C squared still. So I go now and I say 2, this is going to be 4 plus 4 is equal to C squared. And 4 plus 4 is 8. Got to take the square root of both sides now, because I'm not looking for C squared, I'm looking for C. So when I do that, I get C right here. Over here, the square root of 8. It is not in simplest radical form, so I need to simplify that. So to simplify that, that's the same thing as saying 4 times 2. Square root of 4 is 2. The square root of 2 stays inside. And there's my final answer. 2 square root of 2 is what the length of that line segment is, using our Pythagorean theorem. We're going to go do the same thing using our distance formula. Okay? Our distance formula is the square root of x1 minus x2 squared plus, not x again, we already did x. Let's try that again. Let's say plus, and then parentheses, y1 minus y2, and square it. So I first need to know the locations of my points. So my first point here is going to be located at -4, +1. My second point will be located at -2, +3. I can then label these x1, y1, x2, y2, and then plug them into formula. So my distance is equal to the square root of -4 minus -2 squared plus 1 minus 3 squared here. This becomes -2 squared plus -2 squared, which this becomes square root of 4 plus 4, which is the square root of 8. And we've already determined the square root of 8 is really 2 square root of 2. For each of these, you should get the same answer when you do both processes. You can see how sometimes the Pythagorean theorem is a faster way to go. Basically, all you're really doing is finding the length of one leg and the length of the other leg. Now, next example, it's going to be the same type thing here. We look at the same stuff, going through the same process. So here, we're going to go through and first do our Pythagorean theorem. So I need to take and figure out the lengths of the legs. And this one is going to be 1, and then we're going to go up here, 1, 2, 3, 4. So remember, my formula is a squared plus b squared is equal to c squared. So I'm going to have 1 squared plus 4 squared is equal to c squared. So that becomes 1 plus 16 is equal to c squared. 1 and 16 gives me 17 is equal to c squared. Take the square root of both sides. And I see that c is equal to the square root of 17. That's the distance of that segment. Using our distance formula, remember the distance formula is equal to x1 minus x2 squared plus y1 minus y2 squared. So I need to first get my points. My first point is located at -1, -1. The second point is located at 0. And then it's located up here at 1, 2, 3, 0, 3. So we go through and plug this into our formula. So this is where we put the square root here of -1 minus 0 squared plus -1 minus 3 squared. We go through and do our little bit of arithmetic here. This becomes -1 squared plus -4 squared. We square each of these numbers inside, so that becomes 1 plus 16. And 1 plus 16 is the square root of 17, which again cannot be simplified. The distance formula and Pythagorean theorem will both yield the same answer. They're just going to get there in a different direction, that's all. You did take and make sure you always pay attention to what you're doing, take your time, and as always, good luck.
I got nothing for you.